Okay, let's look at this graph. Randy took some ice cubes from the freezer and put them into a beaker, just like this. Now he measured the temperature of the contents of the beaker every 5 minutes and plotted a graph to show his results. So we have ice, which is at about 0 degrees. So at A, therefore this picture here shows the graph at A, right? 0 degrees. Now what have we learned so far? We have learned that just a revision. We've learned that there are 3 states of matter: solid, liquid, and gas. And when solid ice, which is right now solid ice, gains heat from the surrounding. Now remember that ice is about 0 degrees, right? Ice is about 0 degrees. Oops. Okay, ice is about 0 degrees, and the outside temperature is about 20 degrees, okay, or 25 degrees. So at 25 degrees to 0 degrees, we know that heat travels from an area of higher temperature to lower temperature. So we have from higher temperature to lower temperature. So heat is coming into the beaker to melt the ice slowly. All right, heat from the outside is slowly coming into the beaker to melt the ice. Okay, so but when the ice is still melting, when the ice is gaining heat, it is still at 0 degrees Celsius. Alright, all the way until it reaches B. Now B is when there's no more ice. Only then can the temperature go above 0 degrees. But when the ice is still melting at 0 degrees, the water inside there will still be at 0 degrees. So A to B is still gaining heat, right? But even though the temperature is not increasing in the graph, but from A to B it is gaining heat because we know that the ice there is melting. Alright, now once the ice has melted like this completely, when the ice has melted completely, you will see that when the ice has completely melted, okay, you will notice that now this is where B begins. When B begins, the water here is still 0 degrees, but it is slowly increasing in that 10 minutes duration. The water is still increasing all the way until it reaches C. Now once it reaches 25 degrees, inside the water is 25 degrees, and the outside of the beaker is also 25 degrees. There's no more heat transfer. Why? Because heat can only travel when there's a temperature difference. When the temperature is the same, there's no more heat gain, but instead the water inside and the temperature outside remains 25 degrees Celsius. Now that is when it is from C to D. Alright, so we know that when ice melts, it always remains at 0 until there's no more solid ice. Then it becomes liquid at 0. Okay, so one more time, if I can just rewind everything just for you. Okay, so we know that Randy took some ice from the freezer and put into a beaker. Right, now we know that when ice melts, there's heat gain. So from A to B, there's actually heat gain even though the temperature does not change. Because from A to B, this is what we call the process of melting. Right, now inside there, the ice is 0 degrees, and outside the temperature is 25 degrees. Alright, so therefore there will be heat gain of the ice from the surrounding temperature. Alright, so when the ice has completely melted, alright, which is at B, now this is 100% water, there's no more solid ice, then the temperature can increase. Alright, so the temperature increase from B to C slowly from 0 all the way to 25. Once the water reaches 25 degrees, which is at C, though there's no more, there can be no longer any more heat gain, because the heat can't travel anymore from 25 to 25. Heat can only travel when there's a temperature difference from a higher to a colder area, and it is the same, it will remain as it is. Alright, okay, so please remember A to B, both of it is all 0, because water can exist at 0 degrees Celsius and ice can exist at 0 degrees Celsius. So at 0, even though there's melting, even though there's heat gain, there might not be any visible temperature difference. Okay, thank you very much.